All right, so here is a review of the Module 6 review sheet for class. I'll just go over the vocab again, even though we went over some of it. Quadrilateral with 4 right angles, that would be a rectangle. There's no guarantee here that their sides are the same length. Center of rotation is when you rotate about a fixed point. So there's the fixed point. That's the center of the rotation. The angle between the image here, I guess that's the image, and the pre-image, and the center of rotation is the angle of rotation, what degrees you're turning it. Polygon with 6 sides is a hexagon, a reflection line upon which the angle, or upon which an image is reflected onto itself, would be line of symmetry. If the line of reflection puts the object back on itself, then it's a line of symmetry. If it's 4-sided with 4 sides the same length, then it has to be a rhombus. 4-sided with opposite sides parallel, parallelogram. Lines that intersect to form 4 right angles would be perpendicular lines. How you prove basically that two triangles are congruent: side, 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 angle, side, angle, side, angle, side, or angle, angle, side. Remember the two that do not work: angle, 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 and side, side, angle. Those don't work. To occupy the same position on the plane is when something maps onto itself, and I don't know that we've really gone over what that word is, so I'm just going to call it map onto itself. We lost the shapes here for this one, so the only one really you can do is this shape, and if we pretend like it's a full shape like it's supposed to be, a big plus sign, then it has these lines of symmetry, and the center of rotation would be here, and it can turn 90 degrees and look the same. Remember, with diagonals and polygons, it has the same number of diagonals as it does sides, so this would have 40, this one would have 10. If I take this point right here and reflect it across the line y equals 2, that's a vertical line down here at y equals 2. When I do that, then I come up with a point that is way down here. It's 7 below, because this one is 7 above, and 7 below this point right here, 7 below the axis, puts it at -9, or below this line of symmetry, I mean. So it's -2 side to side, and then -9. Finding the slope of these, call this point 1, call this point 2. X always comes first. This one's 3/2, and that one is, this would be a -3/2 really, because if you have a negative on the bottom or the top, it applies to the whole thing. Okay, this one here I chose to do this side, this angle, and this side, so that goes with the short side over here to the short side, the hypotenuse to the hypotenuse, and then the angle in between. Remember, with side angle side, that angle has to be sandwiched between the two sides. So the triangle is triangle ABC. A corresponds to angle E, B to F, and C corresponds to G. The next point here would be 0, -5 if I just keep going. So this is down 3/1. Rotating this by 180 is easy because it just flips it around basically. So J prime, K prime, L prime would look like that. Sorry, somehow that wasn't focused. Flipping it over here. Somehow this problem got messed up. It's not supposed to be a triangle, it's a polygon. They don't even tell you which is the original, but I guess you can kind of figure it out from the shapes. But this is the original one. T is the one that's rotated. So this guy has been rotated like that. So it's right there. This one here is a reflection across this line right there. This one is a translation, a slide kind of diagonally down. If you rotate this one by 90 degrees clockwise, you get something over here, and then take it and reflect it, boom, it puts it back over here. So A double prime is right there. For this one, I graphed point X, then I graphed the line y equals x minus 1. Remember, this would be the y-intercept at -1, so I did that. The slope is 1 over 1, because there's no number there, so it's a 1. So I go up 1 over 1, drew in the line, turned it vertical. I go straight to the line, and then go straight past the line the same distance and make my x prime. If you take this guy right here and reflect it over the y-axis, then you get the one in blue. And then if you take that and slide it diagonally down, 2 down, 1 over, you get the same shape. But this one's messed up as well. That should be up there higher. This should be labeled A. I plotted these guys right here and found the slope of each segment. So this is A, B, C, D. Slope is -11 and 1/11. This one's -11 and 1/11 for the other two. So these two sides are parallel. So that would be this one and this one, because they have the same slope. These two lines are parallel at 1/11. And remember, when lines have the same slope, they're parallel.
I just wanted to remind all the students and staff who are donating blood tomorrow, please remember to eat a good dinner tonight, get a good night's sleep, and drink lots of water. Stay well hydrated. And remember tomorrow, please eat a healthy meal 2 to 3 hours before your donation. And thank you for your donation.
When lines are parallel, they have exactly the same slope, like a -11 and -11, and 1/11 and 1/11. When they're perpendicular, their slopes are negative reciprocals. So if you take -11, flip it over, you get 1 over -11, and then make that negative, and it becomes positive 1/11. So we definitely have a rectangle here. If you have questions, come in Thursday morning or at lunch, and I will answer them. Thanks.